আসসালামু আলাইকুম everyone. কেমন আছো সবাই? আশা করি সবাই ভালো আছো. So today we are going to discuss about the single channel queue problem. So we're going to have lecture 4. So let's move on. So this is the simulation of queuing system we can see here on the top. So this is the example for single channel queue. So in the system we can see that in this diagram that there is some arrival of customers, there is a server, there is the checkout counter, here it is given, so only one checkout counter, and there is a departure for the customers. So this is the system for single channel queue because customers will maintain a queue to get the service from checkout counter. So that's why they will stand in a line, and after getting service they will leave the system. So the assumptions are given here, only one checkout counter and customers arrive at checkout counter. There are some inputs. So suppose customer one arrive in the checkout counter at random time from 1 to 8 minutes apart. That means this is the inter arrival time. So inter arrival time is given 1 to 8 minutes. That means the inter arrival time can be 1, can be 2, 3, 4, 5, 6, 7 or 8. Max 8, minimum 1, the inter arrival time. What is interval time? Interval time means the difference of time between two customers. Suppose that customer 1 has come at 9 a.m. and customer 2 will come after 5 minutes. So 5 is the interval time here. So customer 2 will arrive at time 9:05 a.m. So if next customer comes after 6 minutes, so if the next customer's interval time is 6 minutes, then the next customer will come or will arrive in the system at 9:11 a.m. That is the interval time. From the interval time we can get the arrival time of the customers. So here another time will be given for the checkout counter, that is the service time. So how many times a customer will get service. So here it is given the inputs. It can be varied from 1 to 6 minutes. So the service time, minimum service time can be 1 and the maximum service time can be 6. So it can be varied between 1 to 6 minutes. So it can be different, actually random. Suppose customer 1 has come at 9 a.m. It will have the time of 2 minutes for getting service, so it will end the system at 9:02. That is the actually service time. Depending on the service time, the customer will leave the system. But if the customer come at 9 a.m. and it needs to wait for 5 minutes to get the access of the checkout counter, so the customer will start at 9:05 and for 2 minutes it will end the or leave the system at 9:07 a.m. Okay, so there will be given the two tables, one table for the inter-arrival time for actually finding the arrival time of the customers, and another table will be given for the service time of every customers. So here we're going to solve the problem for 20 customers. We're going to analyze the problem for 20 customers. How can we do that? So let's move on to the next slide. So here we can see the distribution time between arrivals and the service time distribution. So whatever I have mentioned in the previous slide, that there will be two time. One is for interval time, that means time between arrival, and another is for service time. So in your examination there will be some probability given for every minutes. These are the minutes, these are not the customer number. Okay, so take notes that these are minutes of interval time, that one customer has come with the sleep of 400, so it is in between the range. So 400 is in between the 376 to 500. So number on that for that customer who has come with sleep number 400, his arrival time will be 4, and the customer will come up another sleep or another random digit for service time. So suppose he has come up with another sleep that is for the service time, and that is 82. So 82 is in between these friends. Okay, so that customer will be given service time for 4 minutes. So we can actually find out the service time or interval time from the random digits. So random digits will be given in your question. Okay, So how to actually generate the random digit assignment or cumulative probability? So how we will find out the probability? We can actually find out, it will be given in the examination, but if it is not given, then we can find out the probability using the law 1 divided by number of possible outcomes. I'm saying again, I'm going to show you what is that. So 1 divided by number of possible outcomes. So suppose here different types of minutes are 8. So possible outcomes for a customer by having a sleep can be 8 different types of minutes. So 1 divided by 8 for this scenario, that will be 1 divided by 8. So if I do 1 divided by 8, do calculation on the calculator, it will be 0.1, 2, and 5. So for every customer, the probability will be mutually exclusive. That will be the same probability if it is not given, because in your examination question it is given that time will be varied from 1 to 8 minutes. So that means there are number of possible outcomes of 8. So 1 divided by 8, we will get that. So from this probability, so I'm going to make it off. So from this probability, we can find out the cumulative probability by sum of the by sum of the probability of the previous customers, or previous minutes. So 0.125 for the first time, this will be 0.125 plus 0 equals to 0.125. Then it will be 0.125 plus 0.125, it will be 0.250. Then it will be 0.250 plus 0.125, it will be 0.375. Like that, it will be end up at 1, because we know that the sum of all the possible outcomes is 1. That is the law of probability. So if we actually sum up all the probabilities, it will be 1. And after actually creating cumulative probability, we can find out the random digit assignment from cumulative probability. So how we will do that? We will start the number with 1 and we will end the number with 0. That is the law. You can also start with 0, and you can also start with 0, and you can also end at 999, like that. But in our class, we will do start with 001 and we will end at the point 1 to 5. So it will be 3. There we can see after the decimal number, there are 3 decimal number after the point. So random digit will be 001. If there were 2 decimal numbers after point, like that 0.10, so there we would take 01. So it will end up 0012 125. Then for the next minute, it will be 0.126. Immediately next number 0.126 to max limit 0.250. So we will do so. So for service time distribution, it is also like that. So it is a note that the last number will be 1000, but as we are going to actually take 3-digit number, so we will take only 000. So 000 will be the highest random digit for minutes. Okay, so take the notes. So for service time, we'll do it like that also. So in this lecture, the service time probability is given. If it was not given, then we can do 1 divided by 6. That would be 0.166 for every minute. So it is given here. So if it is given, then we can actually find out the cumulative probability and we can do random digit assignment. Okay. So go to next. So going to next. So from this, actually random digit will be given in the examination. So from this random numbers, we can actually find out the time between arrivals. Suppose customer 5 has come up with the random digit 948. So we can find out the minutes for the customer 5. So 948 is in between the range for interval time. So it will have 8 minutes of interval time. So we can see that it has 8 minutes of interval time. Okay, so you can find out for 20 customers. So but take a note that there will be no random digit for the first customer. Okay, because the first customer has no interarrival time. Take notes, because it will not come after some customer. It is he is the first customer. After him there will be a lot of customer. Okay, so we will not take any random digit for customer 1. Similarly, we will find out the service time using the random digits that will be given in the examination from the customer number. So customer, suppose we are going to check. So customer 6 has come up with 79. What will be the service time? Here we can see that that is 4. So going to show that. So let's prove. So customer 6 has come up with the random digit 79 for service time. So we will look over the service time distribution. 79 is in between the range, so it will have service time of 4 minutes. So accordingly, we will find out the other customer service time. Then we will generate this table. This is the single channel queue table. I'm going to show you all the columns. So here the first column is for customer, second column is for interval time. That we also can say that time since last arrival or interval time. So from this we can find out the arrival time. The service time we will find out from the random digits that is actually given here. This is the service time begin. We will find out this from all the previous data, and time customer waits in the queue, time service ends, that means when the actually customer leave the system, the time customer spends in the system, that means how much time a customer were in the system, and idle time of server, that how much time the server was idle after actually getting the first access. Okay, so let's have a look, or let's demonstrate for customer 1. So customer 1 has no random digit, that's why it has no interval time. So by default it will be started by 0. Okay, arrival time is 0. So it has a service time of 4 minutes. We have found out the 4 minutes from the previous tables. Okay, from the random digits. So we can also add the 1 2 column here. A1 is for a random digit for interval time for making it short, and C1 for random digit for service time. We will elaborate that later. So service time is 4. So let's have a look. So it has come at time 0, service time 4. So it will start the service as there is no one before him. So it will start service at time 0, and he will actually end the service at time 4. And he has no waiting time. Okay, because he has come at time 0 and also started the service from time 0. The customer time spent in the system, that is actually the summation of waiting time plus service time. So we can see that there is no waiting time, and service time were 4 minutes. So the customer spends in the system 4 minutes. We can actually find out that you thinking like that. We can find out thinking that arrival time was 0 and ending time is 4. So this time customer were in the system, so the time is 4. So it has come at 0 and it has ended at time 4. So the customer time spends in the system is time 4. So idle time is server is 0. How? Because the server was not idle, because after actually immediately starting the server, it has begun to give service of the customers. So let's have a look for customer 2. So after 8 minutes of arrival time of customer 1, it will come. So after 8 minutes, it will have the arrival time of 8. So if the customer comes at time 0, it will second customer will come after 8 minutes. That means the arrival time is 8 minutes. So third customer will come after 6 minutes of after second customer. So it will be have 14 minutes. So after, fourth customer will come. We can see like that after 1 minute. So from where we have got that? We have got that from the previous tables using random digit. Okay, so random digit will be given. So we can actually make the tables from the random digit, and we can also actually find out the interval time from there and service time from there. Okay, so let's have a look for number 2 customer. So it has come at time 8. It has a service time of 1, and it will begin the service at time as it has come at time 8. So it will start the service from time 8. So how much time, after how much time it has started? 4 minutes. So previous customer, for the previous customer, server actually ended its service at time 4, and again it started at time 4. That means the server idle time is 4. For 4 minutes it was stopped. Okay, so there is no waiting time because customer has come at 8 and it has begun its service at time 8. That's why there is no waiting time, and the service time is 1. That's why it will end the service at time 9. So customer spent in the system, that means how much time customer were in the system. So customer came at time 8, customer will actually leave the system at time 9. That is why this is 1. It has spent the time in the system. So idle time of customer is 4, because why it is for the server idle time, because the previous customer ended the service at time 4, and this customer has started its service at time 8. That's why the server was idle for 4 minutes. Okay, so accordingly we can find out all the customers, and we can find out we can actually build the table for 20 customers. So from this table we will have to analyze, and we will have to find some outputs to analyze the outputs. So this is very easy. Average waiting time, so the total time customers wait in queue divided by total number of customer. We can use the law to find out all the things. So the probability, here we can see the number of customers who waits. So we can see from the previous table that number of customer who waits, so there were 7 customers, 1 2 3 4 5 6 7. There were several customers, they had no waiting time, and so among 20 customers, so 13 customers actually waited. So the probability, the law of this equation to find out the probability of a customer has to wait in the queue is number of customers who waits 13 and total number of customers were 20. So you can find out like that. And the fraction time of idle time of server, that is also the probability. We can find out the total idle time of server. So total idle time was 18, and runtime of simulation is 86. We can see that. So runtime is 86, and total idle time of the server was 18. So we can find out the probability of server also. Okay, the probability of server of idle time. Okay, so from that we can find out the busy time also by actually subtracting from 1. So we can find out the busy time, because we know that p plus q for the probability of failure and probability of success equals to 1. So if we sum up the probability of failure q, and the probability of success is p, it will be 1 by addition. So we can if we get the things, the idle time, we can find out the busy time only by only by subtracting from 1. We also can find out this idle probability of busy server by like that, total busy time of server. So if the idle time is 18, so busy time will be 86 minus 18, that means 68. So it will be 68 by 86, that will be also 0.79. So similarly we can find out other laws from here. So that's all, and finally we will find out the average time customer spends in the system is 6.2 minutes. So that's all for today about single channel queue. And the double channel queue is very much easy, very easy. From that, there will be only, I'm going to show you, there will be only 2 server and only 1 channel. Okay, thank you everyone. So let's get back to lecture of single channel queue. So we have actually known about a lot of things about distribution tables of service time, interval time, random digits, and also the scenario of single channel queue, how to find out and how to calculate the full table from the here, and how to actually get the outputs. So thank you everyone for joining with me. Assalamu alaikum. I'm going to end this session.